All right, now headphones are on. Let's record this. So here's our next lesson. We're going to learn how to write prime factorizations of composite numbers. So how can you break down all the prime numbers that are the factors to make up that number? Here's your first warm-up. Let's just see if we can identify what's prime or composite. Take a few minutes, hopefully not more than that, to come up with the answers. Come back when you're done. All right, so I was a little lazy. I just wrote P or C. But there's only 2 of these 6 that were actually prime, so 1/3 of them was prime. The other 2/3 were composite. 57 is composite. That's one that some people forget. But if you add 5 and 7, what do you get? You get 12. 3 goes into 12, so you know 3 goes into 57. Okay, now that our brains are warmed up, let's get into today's lesson. Let's start with some notes. What's a factor? What's a product? What are these? How are these numbers connected with division? Well, whole numbers that are multiplied together, we call those factors. The result you get of those 2 factors is a product. So usually what you're doing to find out if a number is divisible is you're taking that product and you're seeing if those factors divide into it evenly. So here's an example that I want you to copy this all down in your notes. You can see how 2 times 3 are factors of 6. And if you divide 6 by 3 and 6 by 2, they go in evenly. So 2 and 3 are considered divisibles of 6, or saying 6 is divisible of 2 and 3. So have that written down before moving on. All right, so let's talk about how you can find the factors of a number. So here we have the number 16. So what I like to do, I kind of call it the factor rainbow, where you list the numbers in factor pairs, starting with the one you know every number has, which is 1 and itself. So here I started with 16 equals 1 times 16. Then I kind of started working up the rules. I know 16 is an even number, so I know 2 will go into it. But how many times do you multiply 2 to get 16? That would be 8. So now you have 1, 2, 8, and 16 as factors. Then you go next number, 3 doesn't work. 4 will go into 16 4 times, so 4 times 4, which is the same thing. And then you start to repeat when you start to see the numbers flip-flopped. And that's when you know you're done. So really, when you're doing it, it's 1 times 16, 2 times 8, and then 4. So 1, 2, 4, 8, and 16. These are the factors that make up 16, or the factors of 16, when you multiply them together. So factor pairs are the 2 numbers that go together that help you with it. And we want to make sure we have this written down before we're moving on. And of course, sometimes there'll be numbers like this, 19, where the only 2 factors that make up 19 is 1 and 19. 2 doesn't go into 19, 3 doesn't go into 19, 4, 5, 6, and 9 and 10, those rules that we learned in the divisibility lesson, they don't work. So only factors of 19 would be 1 and 19, and we call that a prime number. I put this down as an example of a prime number and its factors, because you still get 2 factors with a prime number. All right, I want you to come up with all the factors of 12. See how well you do at this. Come back when you're done. All right, so let's see how you did. So 12, we know 1 and 12 go into 12, 2 and 6, 3 and 4, and now we're starting to repeat at 4 and 3, so you're done once you start seeing the numbers repeat in opposite order. So 1, 2, 3, 4, 6, and 12, these are the factors you should have gotten. Maybe you got only a couple of them. If that's the case, you need to remember to go through those divisibility rules and see what are all the numbers that can be divided to make 12. All right, try one more here on your own. Hopefully this isn't too hard. Find the factors of 11. So 11 is a prime number, so that would mean only 1 and 11 are the only 2 factors of that number. And you should have remembered 11 is a prime number, so 1 and 11 are the only correct answers to this question. All right, let's talk about figuring out a factor's prime factorization. So the definition at the bottom, I want you to copy that down. But if we're trying to figure out factorization of 12, there are two factors that go together. 1 and 12, that's a factorization of 12. 2 and 6, 3 and 4, but so is 3, 2, and 2. So factors can be more than just two numbers. And in this case, if we broke down 4 into 2 times 2, slide it down a little bit, into 2 times 2, all of that works together to give you 12. 3 times 2 is 6, times 2 is 12. So the prime factorization is looking at the numbers that multiply up to get 12. But if you notice with this one, this is the only one that all three factors are prime. And when that happens, that gives us a prime factorization, breaking down a large number into all the little itty-bitty primes. Let's work on that here for example 2. Make sure you have these notes before moving on. All right, so the method I want to show you here is the factor tree method. So making a tree without ornaments, we're making this fancy tree here. So what you do is you first find out what number you're being given, and you start out by finding two factors that can give you 24. So two of the factor pairs. So in the two scenarios we have here, and you only have to copy one down. For 24, what if we notice that they're even, so we just do 2 times 12? Well, as soon as you hit a number that's prime, 2 is prime, you circle it, and you're done. But the next branch of 12 we can break down even more. 2 times 6 gives you 12. So you can see we circled 2, but 6 is still not a prime number. 6 can be broken down 2 times 3. So your factor tree is done once every little ornament at the end of the branch is a prime number. So you can break down the prime factorization of 24 into 2 times 2 times 2 times 3. And if you multiplied all those together, you get 24. Broke it down a different way with two different prime factors here of 6 and 4. 6 and 4 are not prime, but you can break them down into 3 and 2 and 2 and 2. And if you look here, you get the same prime factorization as the other one. Now, you can write them all out like this as 2 times 2 times 2 times 3, or you can start to use exponents. And notice that we have 3 2's that repeat, so you could do 2 to the power of 3 times the 3 that's left over. So have this example down before we move on in our notes. All right, it's your turn. Try to find the factors of 28 and break it down for the prime factorization of 28. So remember, choose any two factors that make 28 first and start to break down each branch until all that's left are primes. Come back when you're done, and I'll show you what I came up with. All right, so there's multiple numbers you could have started with. I chose 7 and 4. And when I looked at 7 and 4, I recognized 7's prime. So the one branch was done right away. But 4 could be broken down. 2 times 2 gives you 4. So this is what you get. You get 7, 2, and 2. So the prime factorization of 28 is either 2 times 2 times 7, or 7 times 2 times 2. Or you can use exponents and do 2 squared times 7. Breaking them down into the exponents helps your math go a little quicker, and it makes it a little neater when you're writing it all down. So hopefully you got one of those two underlined answers as yours. You may have started with different numbers. I'm going to guess most of you probably did start with 7 and 4. Or you did 12 and 14, and you worked that way. All right, so let's move on to the box of thought, or box of thought. Here are your 3 answers. Tell how you know when you found all the factors of a number. That's what we worked on in example 1. Tell how you know when you found the prime factorization of a number. That's what we worked on in practice 2. And explain the difference between factors that are prime, factors of a number, and prime factors of a number. So what's the difference between doing number 1 or doing number 2? Come back when you're done. Here is your quiz. First 3 questions you're going to do is list all the factors of each number. The last 2, you're going to break down the prime factorization of them using the factor tree. All right, that's our lesson. See you